And you're going to find that I've been recording lectures in this course since 1991. Now, you don't have copies of them, but you'll find about the last 6 or 7 years are listed on the web, okay? And what I learned in 1991 was that recording the lecture, I did it in the first experiment MIT ever did to give credit at a distance, okay? And that was in 1990 or 1991. And General Motors had asked for my welding course because they gave master's students to students from RPI and Purdue, or degrees from RPI and Purdue, but they wanted a welding course, and they looked around the country and they thought that I would do the best job on a welding course. So they asked MIT if they could have the students sign up and get credit at RPI and Purdue. And that was the big joke, whether I could qualify my course to get graduate credit at RPI and Purdue. I did succeed in doing that. But nonetheless, this was delayed video instruction, which something Stanford had started in the 1980s, where they would videotape a lecture, they would then send it to a company, and the company might have 10 people, 10 engineers taking the course by delayed video, and they would have a TA, which may just be one of the students, because these are engineers who have been working for a number of years, and they were getting advanced courses at Stanford. And they found that the students at Stanford who did tutored video instruction did better in the class than the students who took the live lectures on campus, which I thought was sort of interesting. And it turns out they did a study and they found the reason, and I found the reason because I went to GM that first fall, and because the students were supposed to ask me a question every class. They were supposed to email me or something, or phone me or whatever and ask some questions so I'd get some feedback. And for half the term, I had gotten like 3 questions from 15 students at General Motors. And I went out they paid for me to go out to General Motors Tech Center and meet the students. And I said, how come I'm not getting any questions? And they said, well, it turns out if we don't understand what you said, we stop the video and play it back. And the second time, it makes more sense, okay? And so I realized that professors are not always completely obtuse, but your mind wanders, or the first time you hear it, it's not as clear, and the second time it actually makes more sense. So that's one of the reasons why tutored video instruction is actually better than live lectures. So I would encourage you to ask questions and interrupt me. You're going to find that I digress, and we'll talk about that. And you'll see that some of the students actually think that my digressions are intended. But anyway, so let me, any other questions? I mean, it's okay if you miss a part of the class. In fact, you can miss the whole class and watch the movie, okay? In fact, they're all on YouTube. I have 120 hours of lectures on YouTube for the last 10 years. And I get emails, I haven't gotten one for 2 days, from somebody in some part of the world asking me questions. Because anybody can watch my MIT course for free. They just don't get MIT credit unless they pay the registrar. So I'm going to share the screen here, if I can figure this all out. I did teach by YouTube this summer. I taught this course. And hopefully now you see my outline of my structural materials intro. And you hopefully see the first slide. This is a completely online version. We've done 80% online versions in the past, so it wasn't too hard this March to switch over. In fact, I basically canceled live lectures the day before MIT sent everybody home in March, okay? I guess I saw the handwriting on the wall that we could finish up fairly quickly. The course has 3 numbers. There's an undergraduate version, 3171, graduate 371, and then 2821 is the mechanical engineering. This semester, there's only 2 lecturers or people that will be doing something live. It will be at 9 o'clock, or 9:05 to 9:55 in the morning. It's not in room 140. I'm in room, or actually that is my office number, sorry. That's my office number, but I'm not going to be there because they won't let me on campus. That's my home phone, and you're welcome to call me at home, or you can email me. We have Dr. Donald Baskin. Donald Baskin is a graduate of Northwestern. He was one of Chris Shue's, our former department head's classmates at Northwestern. He went off to Daimler Chrysler in their design group on designing lightweight frames for automobiles. And I'll show you some more. But he taught 6 lectures last spring. He's going to redo those live on Thursday mornings, okay? But he's going to add an extra lecture because he didn't get to all the things that he wanted to before. I'm going to have live recitations. There's 120 hours of my lectures already on YouTube. I'm going to show you where to find them. And probably we'll schedule the recitations at students' convenience or my convenience. I think the next one might be next Monday. We might do a regular one with Tom Eager on Mondays, and Don Baskin will be a regular one on Thursdays. We can't do next Monday, it's an MIT holiday, so maybe we'll do, well, I can't do that either. I got something at 9:30. Well, maybe we ought to try to do this Friday, okay? But I'm not sure, and you'll get to ask questions at my recitations. Hopefully you'll be watching, we're calling flipping the lecture. You get to watch my lectures on YouTube, and you're all going to be watching different lectures because you get to pick your own lectures. Don Baskin is going to give a set of 7 lectures, which will become one of the modules in the course. And you'll learn more about modules. Administrative details, there's going to be, I used to pass around sign-in sheets so I get to know who you were. The registrar doesn't let me know who you are for a month. But if you'll send your name, email, course, and year to Jerry Hill, there's their email address. And this will be posted on Stellar after this morning. Jerry Hill is my assistant, and she will keep a list of all the students. And from that, I'll keep track of who you are. It became fully online because of COVID-19. We actually did it starting this summer. I teach this course summer, fall, and spring. Class schedule is eager to be arranged. We're going to try to, well, we'll do this Friday, and then the week after that, turns out I may be tied up virtually every day except Monday, and that's a holiday. Students will have to do a presentation. I think there's only about 15 to 20 students this semester. And you have to do a 10-minute presentation. What I did this summer, and I had 13 students, is we had my recitations become some of your presentation time, which means it may be more than just 1 day a week. It could be 5 days a week. And you don't have to attend all of those. We'll videotape these, and we won't put those on YouTube for the world, but we may put them on other things. So, because I'm going to want you to watch some of the other students' presentations, and you'll see more about that. I like to describe the course as flexibility in a stress-free environment, and I'll explain it. And I am flexible, okay? If you have a problem or an issue, you have to leave early. Those types of things are fine. We've designed this to be flexible. Available modules. I used to teach it in 12-unit modules, and historically, going back 35 years ago, I was teaching solid state welding and fusion welding. Someone was asking me at the beginning what my area of specialty is. I got my tenure in welding, okay? I am Mr. Welding for much of the world, okay? And then when Professor Masabuchi, who was in course 2, actually was in ocean engineering, He was an expert in welding. When he retired about 1998, I started teaching welding metallurgy. So there are about 50 classes around welding, these three modules. But I've also taught total quality management, and I have a little different take on what TQM is, the good and the bad. Material selection, these are spring and fall semesters. If you look at some of the numbers, I don't know if you can see my cursor. I taught one on what is engineering because I was trying to figure out what's the difference between a scientist and an engineer a few years ago. So I taught 12 lectures on what engineering is all about. One of my favorites that the students don't seem to think is important is codes and standards. When you get out in the real world, you find that half of what you do is controlled by codes and standards. And some of these have the force of law because they are adopted by governments, US government, state government. Deformation processing was one of my early loves, if you will, and that's forging and rolling and shaping. I took a course from a professor who I had great respect for his intellectual knowledge. He was my first person I worked for as a sophomore. Whoops, which way am I going here? Al Backoffen, and I used to teach his course when he retired. Materials processing and casting, there's a module on that. Material selection and economics, there's a few others. Other people have lectured. Simone Belmar is a mechanical materials engineer, got his PhD in course 3 in mechanical behavior, and he's taught various types of structural materials courses. And so he's got a number of modules that are there. So I may have 120 hours, there's probably another 80 hours by other people, okay? Dr. Belmar will not be lecturing this term because he's off starting his business for the last 3 or 4 years, and he's gotten too busy. But the business has grown to about $4 or $5 million in sales, and he has a way of non-destructively testing the tensile strength of a material. And hopefully he may develop a way to get the fracture toughness of a material non-destructively. And that's the billion-dollar payoff, as I call it. Neil Jenkins was one of my students, got a undergraduate and PhD at MIT. He went on to get an MD. So he's an MD, PhD. And when I was on sabbatical in 2015, he taught non-destructive evaluation of the human body, which is basically, what does a doctor use when you walk into their office for an exam? And it turns out he uses the 5 senses: sight, sound, smell, touch, okay, to evaluate what's going on with you. And that's kind of interesting. And then Steve Lyons is a graduate of the Sloan School. He is the Lyons of Kleinman and Lyons, which is a law firm at One International Place, one of the high rises in Boston. In the last 5 or 6 years, he's been lecturing every spring on intellectual property. That's his specialty. In the last 5 or 6 years, he's lectured, or he's argued cases in front of the US Supreme Court on several occasions. So Steve is no slouch as an attorney. The course really belongs at the Sloan School, but there's another professor at the Sloan School who teaches an intellectual property course, and he's preventing Steve from volunteering to teach at the Sloan School. So I've given Steve a chance every spring to lecture 12 lectures to the students, and they really like it. What do you have to do in this course? You have to watch 30, well, before I go on, does anybody have a question? If not, then I'll keep going. You have to watch 36 lectures. So a 12-unit course at MIT is basically about 36 lectures, okay? So you've got to watch 36 of these lectures. In the past, I would say you had to watch 6 modules, which is about 6 lectures. But the modules are not all 6 lectures. At this point, you can watch whatever you want, as long as you watch 36 lectures. How do I know if you watch 36 lectures? You've got to prepare a one-page outline of each lecture module that you watch. In this case, every lecture you watch, since now that it's online 100%, you can watch any lecture you want, and they don't have to be a set of lectures. I found some students who were listeners were just picking and choosing what they liked, and you can do the same. Okay, we're flexible, but you've got to write down 1 or 2 lines describing the 2 or 3 themes of that lecture. And I tell stories. Okay. And the story about the theme of a lecture is, in my junior year, for some reason, in the fall term of my junior year at MIT, this would have been 1970, I was in course 3, and I decided for some stupid reason to take one of my electives in physics in a course called Introduction to Quantum Mechanics. My lecturer was Vera Kestiakowski, first woman tenured faculty member in physics at MIT. Her father happened to have won the Nobel Prize up at Harvard in chemistry. Vera was brilliant, and she was a very good lecturer. But I didn't have a clue what was going on in this class. I was getting 15s out of 100 on the homeworks, when everybody else, the class average was 85 on the homework, and I'm getting 15. And the night before the lecture, I figured, well, I'm going to flunk this class. And so I took the book, and I just kind of sat down, and I went through to figure out what the high points were. I walked into the class for the 3-hour final, and I finished it in an hour and a half, and checked it over, and turned it in, and I ended up getting an A in the class. I aced that final because, as I analyzed it afterwards, I just figured out what the high points were. And I came to learn that 90% of what the professors cover in class is just fluff. It's additional material, but there's only 1 or 2 or 3 themes. This is the maximum amount a professor can get across in a lecture. And you have to learn how to identify the theme. For the rest of my career at MIT, the rest of my undergraduate and graduate career, I never took any more notes in class. I just sat there trying to figure out what the professor's theme was for that lecture. What was the lecture all about? Could I reduce it to a soundbite? And I quit studying for quizzes because if I understood the themes, I could go take any quiz if I'd been paying attention and doing the homeworks and things like that. So you get to try, I'm going to try to, and I think the students have, over the last 4 or 5 years have found this useful, at least some of their comments, is you have to, after you watch a 1-hour lecture on YouTube, you need to write down what you think the professor's theme was of that lecture. And it's amazing to me, the students are watching the same lecture, but what they write down as the theme, you wouldn't believe they were watching the same lecture. But you're a product of your environment. You will pick up the themes that make sense to you based on your previous experiences. And that's actually what learning is all about, is building on the past and then increasing it. And if you learn to figure out what was this 2 hours of this hour about, in just 2 or 3 lines. And so typically for the whole course, you only have to turn in about 3 pages of summaries of your 36 lectures, okay? And if you do it after the end of each lecture, it's a pretty easy assignment. You got to prepare a 10-minute presentation, okay, on a materials topic of your choice. We'll talk more about that. Sorry. I don't know what I'm doing here. Prepare a 10-minute presentation on materials topic of your choice. Attend at least 6 other student presentations. You can do that on the live recitations, or you can watch them. And I may ask you to evaluate the student's presentation So the students get more feedback than just from me, okay, on the presentation. I put in bold here, explore topics, people of interest on the web. I used to hand out a bunch of archaic references that you could read as expansion on some of the materials. And I haven't kept that up. But what I found is if the students are free to explore whatever they're interested in on lectures and instructional materials or intellectual property or whatever, nowadays, if you're interested in that, or if you want to know who some person was, you can Google it and you can read a Wikipedia article about that person or about that topic. And I would hope that after you've watched an hour's lecture, you might have jotted down a few things and you'll spend another hour or maybe 2 hours exploring on the web on your own topics, history of interest that came out of that lecture. For example, I had to worry about someone who made a bad, wasn't a solder joint, they were joining copper tubing, which now uses something called ProPress, which is a new technique over the last 10 or 15 years, but everybody's using it, okay, in the construction industry. And so I had never really studied it, so I got and started looking at ProPress equipment. And I know what it costs now. It costs about $1,000 to get a good ProPress tool. And I've watched videos, YouTube videos on how to do ProPress and why the companies think it's better. I'll tell you the real reason they think it's better, because it doesn't require a fire watch. In the old days when plumbers would go in and use a torch and a flame to solder someone's pipe, every now and then they burn down the building. And so places like the city of Boston, the fire department said, you must hire a Boston firefighter to be the fire watch while you're a plumber working in a building with a torch. Well, that cost a small fortune. It was great for the firemen. They got extra work, overtime work at a premium rate, but it cost a small fortune for the plumbers. But then ProPress came along, and now you don't have to have a fire watch because there's no torch. And it's faster, it turns out. The equipment might be more expensive and stuff, but the whole process is faster. So you kind of learn something about the whole system of putting copper pipes. My office at MIT was redone a few years ago, all ProPress, okay? No fire watches necessary. That's just an example of something you can learn. And I actually want you to learn that on your own. How do I enforce it? I don't. If you want to pay tuition for not learning, that's fine. MIT will accept your tuition. Presentations, 10 minutes maximum. Sources reference, we'd like to know where you got your information. I will probably give you one or some examples of things that were done this summer. Actually, I got them right here. Let me go back one. Every time I hit my mouse. Attend and comment on other students' presentations. The topics this summer, I had 13 students. One was on metal brushes and motors. This person had worked on it, and when he was at the University of Virginia. One professor had a consulting company that they had started on improved metal brushes for commutators in motors. One was on iPhone glass. How do they make the glass that goes into your iPhone? It's a toughened and glass that if it gets a scratch on the surface, it hopefully won't shatter, okay? Shannon Reddick's method is a way to do failure analysis, and this student had done it. And they wanted to share their experience with using this failure analysis technique. Another student did non-destructive testing. It was too broad a topic, but they chose it, and we won't have to get into it. Fiber optics cable. How does Corning make the fiber optics cables? Tremendous amount of stuff on the web. The World Trade Center collapse, okay? Sailboat keel failures, okay? Tesla production hell. Now this one was an interesting one. This is a U.S. Navy student who was interested in how Tesla manufactured automobiles, and I may put this one on the website. I have his permission, but he got a tremendous amount of information just off the web. I was amazed at how much he could get just off the web about all the production problems that Tesla had with their automobiles. Another was a Coast Guard officer, and he talked about the Coast Guard tried to convert some of their patrol boats and lengthen them by 20 feet or something. Anyway, these are some of the topics. The topics will be best if it's on a materials topic of your own interest, okay? If you're not interested in the topic, I'm not forcing you to write about something you don't know about. And in fact, if you want to tell us about your doctoral thesis, that's fine, okay? I'm not asking you to do anything extra that you haven't already done. I just want you to present it in a coherent way to other people. This is an opportunity for you to teach others about something that is of interest to you. I've had students do flying buttresses in cathedrals in Europe, and why, you know, how they worked and why they worked and whatnot. I've had them do pole vault poles, which I found fascinating to see how the composite of a pole pole is designed to have variable flexibility along the length of the pole with that, and have tremendous ability to store energy and spring the pole vaulter up above the bar. So any materials topic you want, 10 minutes, don't be too general, don't be too broad, don't try to cover too much. But add your own analysis. I want to know what you think about things. So we're looking for your critical analysis of a topic that interests you. One topic I'm working on now, just in my consulting, is frying pans, multi-layer frying pans, okay? You can, lots of people make stainless, stainless, aluminum, stainless, and stainless, copper, stainless. Sorry about this. I'm going to stop this. You can do any topic you want, and you'll find that simple topics like a multi-layer frying pan have a lot of interest, a lot of information and technical depth in them that you may not have realized. 3 requirements: no quizzes, no finals, no tests. That's what flexibility is all about. I hated taking tests. I despised it. It's particularly 3-hour finals. I would search for courses that did not have a 3-hour final. Okay, and it was an important consideration on whether I took the course. I hated 3-hour finals. You've got to tell me by a week from Friday what your proposed paper topic is. It's a half-page maximum. Just tell me, what are you going to talk about? Because I may try to organize it. Some of you may be ready to go. If any of you are ready to go this Friday, 1 or 2 of you could go this Friday when I do the next recitation. And certainly we're going to want to have 2 or 3 students go every week, if not more. So we'll have multiple recitations. So I have to tell you certain things, and one's about collusion. This is requirements, rules of the faculty. There is no issue of collusion in this course. You can talk to anybody you want, okay? Because there's no quizzes. You can't cheat if there's no quiz. You're evaluated on your presentation and participation on other things. Your presentation is due as soon as we can start them, but no later than, let's finish by Halloween, okay? That's not completely arbitrary. We're supposed to finish the course by Thanksgiving. Your 1-page outlines of the modules you watched is due the day before Thanksgiving. And attend some, not necessarily all, the student presentations. Many students say they learned a lot from the presentations. So, coming back to the list, anybody have any questions on the requirements? And
Yeah, I have
Andrew,
a question.
yep.
So it says the paper topic, is the paper topic the presentation topic, or is that the same thing?
Yeah, I said paper. In the past, when I have 40 students in the spring, I can't listen to 40 presentations. With only 15 students, I will listen. I'd rather do the presentations. They're more interactive.
Okay.
And they're easier for you. If I said paper, it's because I copied this from my 2017 version of the intro. And so when I said paper, change anywhere it says paper to presentation. Okay. Sorry about that. Okay. It's a problem of recycling. Okay. Any other questions? See, it's easy. And if we do this well, I used to try, when we met as a class, I used to try to front load everything to the first half of the term. And since there's no quizzes, there's no requirements, and all of it's online now, you ought to be able to finish this course. We ought to really be able to finish it by mid-October, not by Halloween, okay? And it does get front loaded to the first half of the term. And believe me, you will be delighted when all the other courses requirements are coming up right before Thanksgiving. In the past, it was right before Christmas vacation. And you were so busy, but this course is done, okay? So I'm also trying to teach you not to procrastinate. I came to MIT as in the bottom third of my entering class. Only a few years, a decade removed from when MIT used to say, get all the freshmen together in Kresge Auditorium and say, look to your right, look to your left. One of the three of you won't be here next year. MIT in the 50s would sometimes flunk out a third of the freshman class, supposedly. I've never confirmed that, but that's what they used to say. Now, MIT is very proud of not flunking people out, but nonetheless, they still have this attitude that learning must be painful. And I think that's ridiculous. And we'll get to that in a little bit. Okay. Other questions?
Yeah, so during the scheduled recitation times, other than presentations, is there really much else that goes on?
Well, you can ask questions, and I love to digress and answer questions. When I don't get very many questions in a recitation, if I get one question, I can talk for an hour on that topic. One of my postdocs took 4 years of my online lectures, and he created a 441-page hypertext document listing 551 stories I had told. Okay. In fact, just to digress a little bit, I'm going to put up another share, which is one of the students' evaluations from a few years ago. And I think this is it. Okay, so now you should be seeing, this is actually a document, it'll be on the web. This is 2014, and this student, student 19472. Though one of the most unconventional classes I've ever taken, meaning 3371 or 2281, whatever, Professor Eager demonstrated inspiring passion, blah, blah, blah. For him, teaching the class and entertaining questions was clearly a great enjoyment to him. I'd rather answer questions than give a lecture, okay? I know what's in the lecture. I've been giving these lectures for 30 years. It's pretty boring, in a sense, for me to hear me talk about something I've been talking about for 30 years. I'd much rather just expound on whatever your question is, because to me, that's what teaching is answering students' questions and helping them understand how someone with more years of experience goes about breaking down a problem. Professor Eager maintained a very transparent teaching style and talked about themes. I've already talked about themes, and now I require you to write down the themes. And I told you the story of how I learned about themes by nearly flunking quantum mechanics. It turns out I got an A in the course by just understanding the themes. I still don't know if I understand quantum mechanics, but anyway, I got an A in the course, and that was the goal. That's part of the problem. That is the goal. Grades are the goal, okay? Provision of examples and object-related current subject. Students are amazed at the number of stories I have, okay, that I've collected over the years. And one of the things I don't get by doing Zoom is I have an office full of touchy-feelies, and they're talking about a beryllium copper wrench that I showed them, which is a non-sparking tool. Steel against steel can produce sparks, but beryllium copper against steel or against other beryllium copper tools will not produce a spark. And if you're deep down in a coal mine and you got explosive gases, you don't want sparks. And it helps make the lectures more memorable. I just told you about ProPress. Well, you may not know anything about ProPress, but maybe after today, you'll go look at ProPress in Google, and you can spend an hour learning about ProPress. And you'll know how people install copper now that they didn't do 15 years ago. They need more reading materials. Well, what I've done is I've decided that so here's some of the students' evaluations from years ago. Now, I found I don't need to give you reading materials. I need you to go out and explore on your own. So about a year ago, we were going to get a new department head, and let me tell another story in the sense that I'm not particularly appreciated anymore at MIT. I was department head, of course, 3 in 1990 to 1995. And I tended to speak up about the immoral, unethical things that I was seeing going on in the upper administration. I wouldn't keep my mouth shut. So when I finally stepped down, actually before I stepped down, the upper administration was trying to squeeze me out of being department head in the first, well, actually for the next 10 years after that, from 2000 to 2010. I was being shunned by the administration. They were doing everything they could to try to get me to take a job somewhere else. Well, I didn't. I enjoy MIT. And the people who are trying to get me to leave MIT, one of them's now president of Boston University, another one is president of a university in Singapore. These people have gone on to what they think are bigger and better things. I happen to be left teaching students at MIT. And Paul Gray, who had once been president of MIT, once said, the best job at MIT is the job of professor. And it turns out as you get up and do things at the upper ranks of the administration, you're glad handing donors, you're sucking up to people who are in the administration above you, you're compromising, you're being asked to compromise your morals and your ethics continually. I didn't want to do that. And so I fought back, and they didn't like me. So I didn't like them either. But now, 20 years later, they're gone and I'm still here, okay? And I'm doing what I want to do, which is teach. So anyway, I was gonna get a new department head. Chris Hewitt announced that he was stepping down. I didn't know who the new department head was gonna be, so I put together some of the comments from the student evaluations, because mostly I teach now. I don't do a lot of research. I'm 70 years old, okay? I'm not gonna last forever. But this is a student from spring a year ago, best class at MIT, eager teaches through sound bites, a method that would greatly serve the rest of the MIT fact. Obviously, he liked it, okay? These are the best. His quotes will be the ones I remember 50 years down the roads, okay? Latitude given to students surprisingly made me learn more than I typically do in a course, allowing me to focus on what I cared about and research that in depth. That's why I'm asking you to go research things on Google. Learn about what interests you, okay? It could be how to make crepes, okay? My wife started making crepes this week again, so she got a new crepe maker and my daughter recommended to her. And so she's been researching how to make crepes, okay? And that's a worthwhile thing to learn, okay? You got to eat something. You might as well eat well. This is probably one of the most useful classes I've taken. I gained a lot of knowledge that I can use in my professional career. I actually think you will learn more in this class about how real engineering is done than you will by taking the academic classes. MIT tries to teach you to be a scientist, and we can talk about what the difference is between a scientist and an engineer. Anyway, so these are some of the best comments. The worst, and I will tell you, I will confess, this is the only bad comment in 4 years. Eager was the worst part of the class and spent a lot of time in the lectures that I watched discussing how to most effectively be a lazy person who doesn't study or care at all about their classes. I was truly disappointed that he's still allowed to teach, which really means to show past recordings of unprepared ramblings on random topics and stories. One of the students actually said the stories were, or he digressed a lot, but that was the point. Okay. So anyway, whatever. This is an outcomes assessment. This is a student in the Navy. It used to be 13A, but it's 2N now. He came here when he was about 30 years old, and he got a couple of master's degrees from MIT. He sent me an email in 2019. He's now head of Norfolk Naval Shipyard, okay? He took this course in 2004, or actually probably 2002. I learned more and was entertained more in your class than in all of my other grad classes combined. Your practical knowledge is what we took away. And another outcomes assessment is from these thousands of people around the world who watch my YouTube lectures for free. Thanks for sharing your class videos online. This guy's an ASME pipe and pressure vessel guy for the union in Wisconsin. He's a welder, a certified welding instructor, a weld instructor, an ASME code instructor. I'm enjoying your welding metallurgy class, best resource I've found to date. So aside from the guy who didn't like my class, and you can't please everyone, okay? That's life, okay? The students enjoy the course because it's flexible, it's stress-free, and you have the opportunity to learn, which is what it's all about, okay? Any questions before I do my last set of things? No? Okay, well, I'll share my teaching philosophy, if I can find it. Here it is. Okay. Oh, I didn't stop sharing. No wonder I couldn't find it. Okay, oops. I thought I stopped sharing. Oh, wait a second. Oh, okay, you should see my teaching philosophy now. Okay. Okay, good teaching makes things simple rather than complex. A lot of professors like to impress you with how knowledgeable they are by making things complex, okay? That's not good teaching. I believe good teaching will tell you what you already know, or at least put things in the context of what you already know, and teach you how to put it together so you can reach your own conclusion. And you're MIT students, you already have the tools necessary to learn on your own, but rarely do anyone ever give you a chance to demonstrate that you know how to do it. Induction, deduction, extrapolation, and estimation are methods that will be useful to you in the future. So one part of it is keep it simple, sometimes called Occam's razor, which was from like the 13th century. And he said it in Latin because that's what the educated people do. But he said, it is futile to do with more things which can be done with fewer, which means keep it simple, stupid. You need to learn rather than just waste your time doing problem sets, okay? You know how to do problem sets. And this is my whole thing about themes. You can only cover 1 or 2 concepts in an hour. The rest is all fluff. The next bullet point, numerical results are easier to grade than conceptual expositions. So the example here is 3y is 15. That's easy. If the student comes up with the answer of 5, you mark it correct when you're grading the exams. I've graded thousands of exams. I know why they give you nice, simple numerical answers. It's quick to grade. That's why they do it. Not because it's the best way to teach you something or to see if you understand and learn something. The best way to do that is actually ask you to write and explain things. And here's the Gettysburg Address, which is actually well written and well explained. But we don't do that because it takes forever to grade those, okay? And then there's a question I always ask the students: why would someone spend an entire lecture doing a derivation in class? You've all seen it. They get up and they solve some differential equation or do some mathematical proof. They make 5 mistakes on the board. They spend the whole hour doing it. Does anyone know why they do that? It's not educational. It's because they didn't have time to prepare a lecture. I learned this in my first year on the faculty. I had to teach my deformation processing course. I'd been gone for a couple of days on travel. I got back. I had a 9 o'clock class. I wasn't prepared. And I looked in the book and there was a derivation. I thought, oh, I can do the derivation. So I did. But at the same time, I realized that's why they do derivations. Not because it's the right thing to do or it's educational, but because they didn't have time to prepare a lecture. I won't go through all the communications because we're basically done, but with time. But this is not just at MIT, but just education in general. I will tell this one last story. So back when I had high school students, my children were in high school, and I used to get up at 4 o'clock in the morning and come down and have some cereal and read the morning paper if it had already been delivered. But the paper hadn't been delivered one morning, and one of my sons or daughters had left their math book on the table, high school math book. So I started flipping through the math book, and I found that the math book consisted of 2 pages on every topic. 2 pages on differentials, 2 pages on factorials, 2 pages on differentials, 2 pages on exponents, 2 pages on logarithms. And I'm looking through this, I thought, I had no idea that teaching mathematics was quantized. You could teach every topic in 2 pages. And I thought, why is that? And I realized the reason is all they were doing is preparing them to take the SAT exam. It had nothing to do with teaching mathematics. It had to do with helping them pass a silly exam. And it might be a silly exam. It helped you get in the university you wanted to get into and stuff. But I'm teaching seniors and graduate students now at MIT. You don't have to compete with each other. All you have to do is go out and learn how to learn on your own. And so I'm not going to teach the way everybody else teaches. And I got tenure. I can do whatever I want. Even though they want to squeeze me out, they haven't squeezed me out. I'm still here. Okay? So I have a different teaching philosophy. And I found over the years, the students have come, most of the students, not all. Some students I found really enjoy taking quizzes because they're so good at it, they can show up all their classmates. Well, that's not a very useful approach either, in my opinion. You're not here to compete with your classmates. You're here to enjoy, well, unfortunately on Zoom, you can't be with them very much, but you're here to learn together and expand your horizons. That's why I don't care what topic you talk about. I don't care what lecture you watch. It's just a set of stories. And the stories don't have to fit together in any particular way. Just enjoy the time you have. Now, the next class is going to be Thursday. And I may only be there for the first part of it to help it get started. Dr. Baskin will start his lecture, and he will entertain questions too, okay? And I've taught him not to fill it up with a bunch of equations, but to talk about the concepts. And I will put on the web one of the papers he wrote. Actually, I guess, anyway, his topic is lightweighting and structural optimization at the intersection of structural materials design and mechanical engineering. Okay, that'll be on the web. In one of his papers that he wrote in 2008 when he was on the design team at Daimler Chrysler, he headed up part of the groups in Germany and in Auburn Hills, Michigan at the Chrysler Tech Center on how to design lightweight automobiles. And he applies this to both bicycles and automobiles. And he uses things like topology optimization, which I didn't even know what it was a year ago. But these are the latest design tools on one of the largest industries in the world, in manufacturing industries, automobiles. And so if you don't know what to watch, that's a good topic to start because the students really enjoyed it. Any questions before I close out? No? Okay, I'll see you Thursday morning, next class. Okay, take care.
Thank you.
Thanks.